Okay, so in this lesson I am going to look at proving identity number 7, which says the sine of angle A plus angle B is equal to sine of angle A times the cosine of angle B plus the cosine of angle A times the sine of angle B. In order to prove it, you need to know identity number 4, which says the cosine of the difference between two angles is equal to the cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. We also need to know this result about the cosine of sine of angles with a sum of 90 degrees. We want the cosine of 90 minus theta is equal to sine theta, and the sine of 90 minus theta is equal to cosine of theta. Okay, so angles with a sum of 90 degrees, the sine of one will equal to the cosine of the other. Okay, complementary angles add up to 90 degrees if the two angles are positive. But we're talking actually about all angles that add up to 90 degrees. So, to prove identity number 7, I'm going to start off by writing out identity number 4, which says the cosine of a first angle subtract the second angle is equal to the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second angle. So that's my identity number 4. Okay. And to prove identity number 4, I'm just going to let the first angle equal to 90 minus A, and I'm going to let the second angle equal to B. And I'm going to substitute those in here. So 90 minus A, I'm substituting in for F there and there and there. And B, I'm substituting in for S here and here and here. And I'm going to rewrite both sides of identity number 4 with my new information. So cosine of the first angle is 90 minus A. Subtract the second angle, which is B. That's going to equal to the cosine of the first angle, which is 90 minus A, times cosine of the second angle, which is B, plus sine of the first angle, which is 90 minus A. Not 9 minus A, let me rewrite that. 90 minus A times sine of the second angle, which is angle B. Okay, and in this first, on the left hand side, I'm just going to rewrite this as 90 subtract. I'm going to factor out this negative sign from these two terms. So what we get inside that bracket is A plus B. So cosine of 90 subtract A plus B is cosine of 90 minus A minus B. Over here, notice 90 minus A, well, that's an angle that adds to A to get 90. It's the complement of angle A. So cosine of 90 minus A, we saw from our previous lesson, that's the same as sine of the angle A. So we get sine of A cosine B. Plus, and sine of 90 minus A, we saw, we have proven that that is the same as cosine of A, sine of B. So cosine of A, and then we've got this sine of B here at the end. And then finally, just to finish off, on the left-hand side, well, 90 minus this angle, cosine of 90 minus any angle, is the same as sine of that angle that you're subtracting from 90. In this case, it will be A plus B. And that will be sine A cosine B plus cosine of A sine of B. And that is identity number 7. And we'll be using identity to prove identity 7 to prove identity 8. A couple of important things. You got to know that cosine of 90 minus any angle is just sine of that angle you're subtracting from 90, and the sine of 90 minus any angle is just the cosine of that angle you're subtracting from 90. Cosine of 90 minus any angle is just sine of that angle you're subtracting from 90. Okay? So rewrite equation 4 like this. Using this notation, it makes the substitution a little bit easier. Let f equals 90 minus A, let s equals b, substitute everything in, and then use the fact that cosine of 90 minus theta is sine of theta, and sine of 90 minus theta is cosine theta. That's identity number 7. Understand the proof, go through it, learn it by